Hi, welcome back to James Ross Island. We have been looking at the geology of this place and looking at how um, lithofacies in the rocks on this island have been defined and then subdivided into the different lithostratigraphic units. I set you then a little task with some simplified data to consider how um, we can actually try and correlate, try and link together the different units we might find in different places. So this is the set of sedimentary sequences that we're trying to correlate here. Now, the first question I asked was about the correlation that's already shown. You can see that we have the fossil zones here defined from 1 to 4 that go across these sequences. So the correlation that's already shown is one of time. These are what we'd call chronostratigraphic units, where the time is defining, or the time of deposition is defining the link between the rocks in these different areas. So, if we evaluate this technique, we can see that we've got a really good time control across these three sites. However, if we look at some of these different zones of time, we can see that there are some similarities. I mean, for example, in fossil zone 1, we've got pretty much the same sedimentary environment in each of those three locations. Things start to get a little bit different in 2, but by 3, there are clear differences between the environments that exist at the same time in these three different locations. So if we're going to link the facies, the sedimentary environments, this technique really isn't going to work well for us. So if we're not linking the time zones, we need to think of another way of correlating these rocks. And perhaps the obvious way of doing that is by using the lithology, by establishing the lithofacies. So let me show you how I do this. So by drawing a series of lines here, we're connecting beds from the same facies, the same rock type, to each other across these areas. So we can start to see some of the lateral change across these three different places. Notice as well we get some what we call isochrons, events that happen at the same time in all of these places. The deposition of volcanic ash can give us a really good marker of a particular point in time. That also, remember, is, well, not remember because we've yet to get to it, but that can also be dated. We can put a number on the age of that event. This technique also shows us how sedimentary environments can change laterally. So we can have different types of deposition happening at the same time in slightly different places. So as a technique, it's a really important one. Remember now in your handout to annotate all the information that you have. It's perhaps unlikely you'll be asked directly a question to remember all the lithostratigraphic units. but you certainly could be asked to apply that understanding, perhaps in a method like the one we've just been looking at. So, as the sun sets over James Ross Island, we have a variety of techniques that we've seen here to be able to link the geology across different places to make this idea of a correlation, and also a way of grouping together similar rock units, ones deposited in similar environments, but then being able to increase the subtlety of our interpretation by subdividing those further into look at individual sub-sedimentary environments. What we need to do next is start thinking about how we can apply fossils in particular to this. But that's for another lesson. I'll see you then.